Hello guys, today we will try to solve the C problem of the 1988 contest, which is named Increasing Sequence with Fixed OR. So let's dig in. Okay, so we will be given an integer n, and our mission is to find the longest sequence of this integer, and we must apply three given conditions in this problem. First and foremost, AI is always less than n. What does that mean? So AI is always larger than 0 and less than n. And secondly, A is always strictly increasing. That means that the yeah, in our sequence of integers, we must always make the next integer more than the previous. And lastly, AE must be AE or AE minus 1 must be n. What does that mean? So in the bitwise OR, when we apply it to integers, the total must be n. Okay, so this is all the conditions in the problem, and let's read about the input. So n is from 1 to 10 18, so just remember to use long, and that is basically it. And here is the test case. Let me copy the test case for you so that we can I can explain it further. Okay, okay. Okay, as you can see, there are four total test cases, and there are also here are the answers. So let's try to find a pattern in those test cases before I try to explain to you guys about the solution. So first and foremost, the first test case when n is 1, then we will have the total of one uh, the total number of sequence is 1, and that is 1, right? And if n is 3, then we have 3 total sequence and total integers, which is 1, 2, and 3. And with 14 there are 4, and with 28 3 there are 5. So let's try to convert these numbers into binary, right? 1 first, 1 will be converted into 1 from decimal to binary, and next 3 will be 1 1, right? And 14 will be 1 1 1 and 0, and 23 will be 1 0 1 1 1. And in our output we will see that when n is 1, the answer will be the total number in the sequence will be 1. In the second test case it will be 3. In the third test case it will be 4, and in the last test case it will be 5, right? So what is our pattern here? Let's see. If we skip the first test case, we can see that the total number of integers in this sequence will be determined by the total number of ones in its binary form plus 1. As you can see in the test case, when n is 3, we have two ones here, and the answer is 3, right? So it is the number of ones plus 1, and the same applies to 14 and 23. So we have that is our pattern, except for the first test case. When n is 1, our answer is just 1. So we can try to eliminate that test case in our code. So that is basically the first pattern I want to explain to you guys. So next, let's try to understand how we can apply this code with the second condition. We must print this sequence with a strictly increasing, right? So how can we do this? So how can we do this? Okay, okay. So let me give you an example. 4, right? 3, right? 3 is 1, 1, right? In the output, we can see that it is 1, 2, 3. And if we write these three integers in this sequence into binary, we will see that it is 1, 1, 0, and 1, 1, right? Mm, wait me a minute. Let's see. Okay, okay. So as you can see, our n is 3, right? So we must try to make the next sequence. Uh, we will try to make the next sequence or with n as n, right? So in this test case, you can see that the n is 1, 1. So we will erase a 0 in the next integer, so that when we OR these two numbers, it will be still 3, right? So 1, 0 is 2, right? When we OR 2 and 3, we'll still gain 3, because in the character where 2 is missing, 3 will be giving it the answer there. And moreover, for the 23rd test case, let me explain this test case to you guys. So like 1, 0, 1, 1, 1. This is 23, right? So how can we do this? So yeah, we can firstly erase the first one in 23 in order to gain the least integer in this sequence. So it will be 0, 0, 1, 1, right? And in the next integer in the sequence, we will return the 1 in the 23rd number, and then we will erase the next one of it, like here, right? It will be 1, 0, 0, 1, 1. And in the next step, we will continue this step until we reach the last number 1 in the original integer. So it will be 1, 0, 1, 0, 1, 1, 0, 1, 1, 0, right? So let's see what the decimal form of all those integers are. So this is 23, right? And this will be 1, 2, this will be 7, this will be 16 plus 2 plus 1, this will be 19, and this will be 16 plus 4, it's 20, 21, and the last one will be 20, 16, 20, 22, right? So let's see, 7, 19, 21, 22, and 23. Oh, my bad. This is 18, right? It's 18, so it's basically my, yeah, this one is 18. Sorry guys, sorry guys. Okay, so as you can see, that's our answer to this problem. And so let's dig in the code right here. First and foremost, as you guys can see, I will run a for loop consisting of 63 integers. So why 63? Because let me calculator here. So if we apply to a 63, it is to a 63, right? It will be more than the long number. So this will be enough for us to cover all the test cases, right? So what will we do? In this code, you can see that I will push the number 1 into the left number of times, and we will end this number with n, so we can check that if e is if there's a 1 in this number of characters in n, and we will make a long integer of TMP, and we will see that if TMP is adequate, or if there is a 1 in the n uh, number. And if there's a TMP, we will push back this number into our vector. And when this for loop is finished, we will also push n into this vector, because as you can see in the answers, there's always n in the last number of the sequence, right? So we will push off these numbers and n into the vector, and we will count the size of this vector, aka the number of numbers in our sequence, and we will print this sequence adequately continuously until this vector is empty. And yeah, that is basically it. So let me run it again. Yeah, that is our answer to this problem. So if you don't really understand any concept in my code, or when I explain it, you guys can always ask me again in the comments. I will try to explain it to you guys more carefully. So thank you.